Hello everyone. Let's solve today's daily problem. Largest triangle area. Okay. So what is given to us? We are given an array called points, and each point has two integers, x and y, which represent the coordinates of the point. Okay. So return the area of the largest triangle that can be formed with any 3 points, right? And then they've also given a constraint that slight inaccuracies are fine. Okay. Now let's look at the first example. We have 1, 2, 3, 4, 5 points. The largest triangle that can be formed is by using the origin 0, 0, and then 2, 0, and then 0, 2. The area of this would be 2, right? Now there are multiple ways to solve this, but today we'll use the most straightforward approach. One more thing you can notice is that the max length of the points list is 50. So even if you don't have an optimal solution, it will still submit since it's an easy problem. So let's go with that itself. Um, what we're going to do is let's look at the first example. Okay, so imagine these are our points. Let's do an exhaustive search. So we'll choose all the ways we can select any 3 points and compute their areas. So initially, this will basically be three loops which are nested with each other. So initially, if this is our I pointer. Our j pointer will start from here and then go up to uh, n minus 2. If n is the size, the index of this will be n minus 2. 0, 1, 2, 3, 4, and the size of the array is 5. So n minus 2 is 3. And then another integer k will go from j plus 1 up to n minus 1. So yeah, after this, you will be able to solve the, yeah, and then I can go up to n minus, n minus 3, right? So n minus 2, n minus 3, n minus 2, and n minus 1. Because if, yeah, we don't want any because the repeated coordinates, because that would just be wasting computation. So let's start. So n is the length of the points, and now let's define. Okay, so let's go over all the points. Let's select any 3 points. So for I in range n minus 2. So we're going up to n minus 3. So that means n minus 2 should be the right limit. So for j in range n minus 1, and then for k in range n. So these are our 3 points. Now let's assign the integers x1 and y1 to point 1. So that would be points of I. And then similarly, for points of j and points of k, uh, let's call them x2, y2, and then x3, y3. And those points of j and points of k. Now we need to find the area of the triangle using these 3 points. Now, if you've studied math in high school, you'll remember that there's something called the shoelace formula. So that is basically, shoelace formula is area of a triangle is given by 3 points. So that is equal to 0.5 into uh, x1 times y1 minus y2. Wait, I actually don't remember exactly. Let's just Google it. Shoelace formula. So it's, I think it's x1 into y1 minus y2, right? Area of a triangle with thrh. Now you can also use Heron's formula after finding all the three sides, right? So this is the formula. Half it to x1 into y2 minus y3, y3 times x2 into y3 minus y1 uh, times s x3 into y1 minus y2, I guess. Yeah, y1 minus y2. Now, I'm not going into the derivation of this. You can Google it. But yeah, using this formula, we can compute the area. So let's just declare a function for that. Given 3 points, we need to find the area. Uh, or we don't even have to do that. Yeah, let's just directly do it here. So initially our result is 0. That means the area is 0. Now the new area, let's say it's 0.5, and then I'll just copy this function right here. Oops. This is a 0, not 4. Let's multiply. It's plus, right? Yeah, this is plus by the way. Yeah, okay. So this should give us the area of the triangle. And then after we find the area using any of the 3 points, we need to assign our result with it if it's greater. So result is equal to maximum of the result itself and the new area. After that, we can just return our result. That should hopefully work. Okay, so there is a small mistake. Now, is it with the formula here? x1, y2 minus y3, x2, y3 minus y1. Okay, now let me just define a function debug, I guess. Wait, no, this should be fine. Uh, I'll debug and okay, the problem was we did get negative area sometimes, which was the problem, and that is quite simple to fix. Just add an absolute, and that should be fine. So yeah, that was the solution using the shoelace formula. Thank you for watching.